NASA's Traveler 1 space mechanical gathering, the farthest traveling space mechanical gathering at any point sent off, has confounded its watchers on its excursion through the universe for very nearly 50 years. Globetrotter 1 has been sending back basic data from the farthest reaches of the universe, by and large driving our view of the universe. Anyway, consistent transmissions from this dumbfounding vehicle have introduced puzzling signs that have left the whole space local area in a condition of miracle and bewilderment. These signs have ignited conversations about whether they are the consequence of a specialized blunder, or then again, on the off chance that they could demonstrate something undeniably more uncommon, maybe extraterrestrial action. Go along with us as we jump further into the secrets encompassing these heavenly transmissions and uncover what may be concealing in the profundities of humankind's revenue in the secrets past. Our planet has been an essential driver in space investigation since its commencement. This voracious interest prompted the exceptional send-off of missions like Trailblazer 1 and Voyager 2, which were among the most aggressive space attempts of their time. The send-off of Pilgrim 2 from NASA's Kennedy Space Center on August 21, 1977 denoted the start of another time in space investigation. Simply a short time frame later, on September 5, Wayfarer 1 followed, making room for an extraordinary excursion. These twin rocket, each gauging around 720 kgr, generally the size of a little vehicle, were sent on an exceptional direction toward the external planets, which assumed an imperative part in their circles and mission results. All through their wonderful odyssey, these space gadgets went this way and that, and at different velocities. A huge second happened on December 15, 1977, when Pioneer 1 overwhelmed its twin because of contrasts in their ways. From that point forward, Wayfarer 1 has arisen as a basic resource, giving critical data that has changed how we might interpret the universe and its numerous peculiarities. Before we dig into Wayfarer 1's latest astounding revelation, which has caught the consideration of the whole space local area, how about we return to a portion of its most eminent accomplishments? In 1978, during its Jovian imaging mission, Pilgrim 1 was situated around 265 million kilometers from Earth. By January 1979, it set out on an exceptional 100-hour mission, catching a period slip by movie of Jupiter's pivot. This series of 3,750 pictures offered intriguing points of view of Jupiter's dynamic climate and its perplexing highlights. The space apparatus disclosures incorporated the recognizable proof of a little ring around Jupiter and two beforehand obscure moons. Essentially, growing comprehension, we might interpret the gas monster's complicated framework to guarantee the space apparatus safe entry and stay away from expected crashes with Titan, one of Saturn's moons. Restorative moves were performed after the effective Saturn mission. Specialists chose to close the planetary mission of both Pilgrim 1 and Voyager 2, yet the space apparatus were sent on another course past the constraints of our nearby planet group, going at an astonishing pace of 325 million km every year. In January 1990, the interstellar mission started, with Pilgrim 1 proceeding with its divine process. During this period, Adventurer 1 made critical revelations, including the ID of 4 extra moons, Mimas, Enceladus, TUS, and Rhea, and caught probably the most famous pictures at any point taken of our nearby planet group. On February 14, 1990, at around 6 billion km from the Sun, it set out on a visual excursion known as the Family Representation, catching dazzling pictures of the inward planets. This assortment of 60 photographs added to investigate one's noteworthy arrangement of 670 photographs taken during its experience with Neptune. Voyager 2 likewise accomplished amazing achievements during its central goal, recording wind speed surpassing 13,100 meters per second, the quickest twists at any point saw in our nearby planet group. This accomplishment gave urgent bits of knowledge into Neptune's far-off air and its biggest moon, Triton, whose surface temperature decreases to a freezing less 391 dF, making it perhaps of the coldest spot in our nearby planet group. Triton likewise showed unprecedented elements, including ice volcanoes that ejected nitrogen gas and pushed frozen particles 5 kilometers into its air. These surprising revelations have widened how we might interpret the differed and complex nature of divine bodies in the external districts of our nearby planet group. The Pilgrim missions have given critical and one-of-a-kind outcomes. Both Pioneer 1 and Pilgrim 2 have uncovered that Jupiter and Saturn's moons, once remembered to be vigorously scarred and lethargic, are really dynamic with geographical cycles. Pilgrim 2 specifically accomplished a few noteworthy stones, including being the primary space apparatus to fly by Uranus and Neptune and stays the main space apparatus to have done so. NASA utilized different procedures to broaden the functional life expectancy of these aggressive space apparatus, including closing down pointless radiators and frameworks to preserve energy. The mission is supposed to finish up in 2030, denoting a snapshot of pride and a sprinkle of bitterness for the specialists and designers who have committed themselves To this phenomenal undertaking, the plan of EXP Adventure 1 and Pilgrim 2 was a wonder of designing. These space apparatus were planned as steady stages turning at a rate in excess of multiple times more slow than a clock-hour hand. This planned decision diminished visual obscuring as the space apparatus crossed the immense area of room. Even prior to arriving at the external planets, the space apparatus started communicating pictures of Jupiter, uncovering its whirling mists and notorious elements like the incomparable red spot, an enormous tempest on Jupiter that enamored crowds at NASA's Fly Impetus Lab. Anyway, the revelation of dynamic volcanoes on Jupiter's moon Io caught the most consideration. The space apparatus instruments distinguished surprising signs from Io, which were affirmed by novel pictures showing transcending volcanic tufts, and a surface scarred by emissions. One of Io's most conspicuous volcanoes emitted with a power multiple times more prominent than that of Mount St. Helens, covering a region practically the size of France. As the space apparatus proceeded with their excursion, their cameras were ultimately switched off to moderate power and memory before they wandered into interstellar space. Surprisingly, the pictures they caught did exclude Mercury or Mars because of different variables. Past the Voyager tests, NASA has sent off other unmistakable space apparatus, remembering Trailblazer 10, Trailblazer 11, and New Skylines for February 17, 1990. 8 Trailblazer 10 passed Trailblazer 11, turning into the space apparatus farthest from Earth. Regardless of the shortfall of other space tests to notice it, Wayfarer 1 proceeded with its performance process for 14 additional prior years, entering interstellar space on August 25, 2012. The progress of the Pilgrim missions was made conceivable through various creative methods, with gravity help moves standing apart as especially splendid. These moves were essential for moving the space apparatus to their far-off objections and gathering crucial information. The space apparatus depended on their own drive frameworks as well as on gravity helps to accomplish their targets. Envision 2 trying space apparatus deftly exploring through our nearby planet group, utilizing the gravitational draw of planets to impel themselves forward. This heavenly dance permitted them to monitor fuel and accomplish the important paces to visit far-off areas. Gravity help moves include moving a limited quantity of a planet's energy to the rocket as it passes by with outrageous accuracy. For instance, as Traveler 1 moved toward Jupiter, the planet's enormous gravitational draw sped up the shuttle. Accomplishing such accuracy was urgent. Any deviation in direction or speed might have prompted devastating outcomes. In spite of the staggering exactness required, the brilliant minds behind these missions effectively executed these gravity assists multiple times, sending the spacecraft on an extraordinary journey. This exceptional campaign, made possible by these celestial maneuvers, saw Pioneer 2 utilizing gravity assists from Jupiter and Saturn to reach Uranus and Neptune. The success of the Pioneer missions owes much to these gravity assists. As we reflect on the phenomenal journey of these exploratory spacecraft and the wealth of data they have provided, we eagerly anticipate further updates on the investigation into Voyager 1's latest anomalies. Both Voyager 1 and Voyager 2 continue their missions beyond known boundaries. Their achievements include exploring Jupiter and its moons, Saturn and its moons, Uranus and Neptune. Voyager 1's time-lapse images showcase 10 eruptions of Jupiter in striking detail, including the discovery of new moons and a small ring. These revelations have greatly enhanced our understanding of Jupiter's complex system. Voyager 1 also discovered 4 additional moons of Saturn, Mimas, Enceladus, Tethys, and Rhea, and took stunning photos of Saturn and its rings, offering new insights into Saturn's intricate system. The spacecraft made history by visiting Uranus and Neptune, providing valuable data about their environments and moons, and enhancing our understanding of the outer regions of our solar system. After completing their planetary missions, Voyager 1 and Voyager 2 ventured into interstellar space, gathering data on the vast cosmic environment. This ongoing research continues to expand our knowledge of the universe beyond our solar system. As we await more information about Voyager 1's latest transmissions and their potential implications for our understanding of the universe, the astonishing journey of these spacecraft remains a source of inspiration and curiosity for scientists and space enthusiasts alike. Their historic accomplishments continue to push the boundaries of human knowledge and exploration, highlighting the limitless potential of space discovery. The Voyager missions have provided us with a treasure trove of information about our solar system and beyond. In addition to the iconic images and data, the spacecraft also carried a brilliant artifact, the Golden Record, a unique artistic message designed to communicate the story of our world to extraterrestrials. This record contains sounds and images chosen to represent the diversity of life and culture on Earth. It includes greetings in 55 languages, music from various cultures, and a selection of natural sounds such as thunder and whale songs. This message in a bottle reflects humanity's hope that, if intelligent life exists elsewhere, they may one day find and understand it, offering a glimpse into the essence of human civilization. Voyager 1 and Voyager 2 were equipped with scientific instruments that revolutionized our understanding of space. These instruments included magnetometers, plasma wave detectors, high-energy particle detectors, and imaging systems, each contributing essential data about space phenomena. For example, the magnetometers provided insights into the magnetic fields of Jupiter, Saturn, Uranus, and Neptune, revealing the complex interactions between these planets and their environments. The plasma wave detectors helped us understand the nature of the solar wind and its relationship with planetary atmospheres and magnetospheres. One of the most remarkable aspects of the Voyager missions is their ability to measure the heliosphere boundary, an immense bubble of solar particles and magnetic fields that surrounds our solar system. As Voyager 1 approached the edge of this boundary, it detected the sudden transition from the solar wind to the interstellar medium. This data has been instrumental in shaping our understanding of the heliosphere structure and its role in shielding Earth from cosmic radiation. The spacecraft's observations have provided evidence of a distinct boundary where the solar wind slows down and becomes denser, known as the termination shock. Beyond this point lies the heliosheath, a region where the solar wind interacts with the interstellar medium, creating a complex and dynamic environment. Voyager 2's journey has been equally significant. After its successful flybys of Jupiter, Saturn, Uranus, and Neptune, it has continued to provide critical data on the outer reaches of our solar system. Voyager 2's observations of Uranus were particularly striking, revealing a unique magnetic field that is significantly tilted compared to the planet's rotational axis. This discovery challenged existing models of planetary magnetism and prompted further investigation into the magnetic environments of other celestial bodies. Beyond their scientific contributions, the Voyager missions have had a profound impact on public interest in space exploration. The breathtaking images of distant planets and their moons, combined with the personal narratives of the spacecraft's journeys, have captured the imagination of people worldwide. The photos of Saturn's rings and the detailed views of Jupiter's moons, particularly Io's volcanic activity, have inspired countless individuals and have been featured in educational materials, documentaries, and popular media. Building on the success of Voyager 1 and Voyager 2, the scientific community has continued to make strides in space exploration. With advancements in technology, new space probes and telescopes have been launched to observe distant regions of the universe, seeking to answer the many unanswered questions left by past missions. These innovations have allowed scientists to study distant exoplanets, black holes, and the evolution of galaxies with unprecedented detail. For example, the Hubble Space Telescope, launched in 1990, has provided some of the most iconic images of the universe, revealing the birth of stars, the nature of nebulae, and the collision of galaxies. The study of exoplanets has become one of the most exciting fields of research in recent years. Thanks to the Kepler Space Telescope and other observatories, astronomers have identified thousands of exoplanets, some of which may have conditions suitable for life. By analyzing the composition of their atmospheres, scientists hope to determine whether any of these planets have the potential to harbor life. The discovery of habitable zones around distant stars has fueled discussions about the possibility of finding extraterrestrial life in the future. Although no direct evidence has yet been found, the search continues. The study of black holes has also seen remarkable progress. These mysterious objects, whose gravitational pull is so strong that not even light can escape, have long fascinated scientists. In 2019, the Event Horizon Telescope (EHT) collaboration made history by capturing the very first image of a black hole located in the galaxy M87. This groundbreaking achievement was the result of combining data from multiple radio telescopes across the globe, creating a virtual Earth-sized telescope. The image provided direct visual evidence of a black hole's presence and its surrounding event horizon, marking a milestone in our understanding of these enigmatic objects. Furthermore, the development of new space missions like the James Webb Space Telescope, JWST, promises to revolutionize our knowledge of the universe. Set to launch in 2021, JWST will provide unprecedented infrared observations, allowing scientists to study the formation of stars, galaxies, and planetary systems in greater detail than ever before. The JWST is also expected to contribute to our search for habitable exoplanets, as its instruments are capable of analyzing the atmospheres of distant worlds, searching for signs of water, oxygen, and other potential indicators of life. In addition to these scientific advancements, space exploration has become increasingly global. Space agencies around the world, including NASA, the European Space Agency (ESA), and China's CNSA, are collaborating on ambitious projects. These include the planned return of humans to the Moon under NASA's Artemis program, as well as missions to Mars, such as NASA's Perseverance rover and China's Tianwen-1. The growing cooperation between nations in space exploration is not only advancing our knowledge of the universe but also fostering a sense of global unity and shared curiosity. As we continue to push the boundaries of space exploration, the discoveries made by past missions like Voyager 1 and Voyager 2 remain fundamental. These early missions paved the way for today's ambitious endeavors and continue to inspire future generations of scientists, engineers, and space enthusiasts. With each new discovery, we are reminded of the vastness and mystery of the universe, and our ever-present drive to understand our place within it.